Hi all, now I am presenting my second assignment on loop subdivision of graphics. Uh, Firstly, we try to understand what is loop subdivision. Loop subdivision is a subdivision algorithm to smooth the curved surfaces by subdividing the triangle mesh that is in the form of triangles into further smaller triangles. As you can see, there are two steps in loop subdivision. One is subdivision, where a triangle is subdivided into four other triangles, and the smoothing phase, where the control vertices, that is the original vertices of the triangle, are uh, originated to a new coordinate point according to its nearest point. So loop has given two equations to solve this problem, and that is first one is of subdivision, that is pi of k plus 1 subdivision step is equal to 3 into pk plus 3 into pk of I plus 3 into plus pk p of k I minus 1 and p of k I plus 1. You can see in this figure, suppose this is my edge. So I have to take a weight of 3 by 8 of both the vertices containing the edge and opposite vertices that are present for the edge. And for them, the weight will be 1 by 8. This is for subdivision. And next will be smoothing. And for smoothing, I have to calculate beta, and this is the equation of beta. And I will take this equation, first equation, for smoothing. Now let us see how we have implemented our code. So I have created a function called create new mesh from loop subdivision. As you can see, for this equation, we need beta, and for beta we need n is the valence of an edge of the vertex, and for subdividing I would require two opposite vertices, and in a phase I get only one vertex. So I have created an edge map which will store the adjacency fit. That means all the vertices that are adjacent to a vertex v1 will be stored in a fit, and I have created a map which will store with the key as vertex v1 and adjacency fit as the value. And along with that, I am counting how many edge counts are there, because for creating a new mesh, I would have to declare how many vertices count would be there and how many faces count. So for faces count, it's easy to calculate because every triangle will create 4 triangles. And for vertices count, I would in the next phase I would require vertices count plus edge count. That means total number of vertices plus edges. So I have created an array, an object, new mesh, and for every phase now I have to find a new vertex with the formula that has been given by loop. So I have written a new method refining new vertex, which will do the calculation for me. That is, it will get v1, v2, and yeah, as I have said, I have created two adjacent fits. So what I am doing is I am taking the adjacent two adjacent sets of both the vertices present in the edge and intersecting it. So it will give me the two opposite vertices. And in case of boundary edges, if there are only one vertex that comes in the intersection set, then I am taking a reflection of that vertex on the edge and then calculating my new vertex. So let's see how how and this refining new vertex is called. So I have taken for every face, every edge of the face, and an edge can be common to more than one face. So I don't want to recalculate the whole vertex again. So what I am doing is I am keeping a track in a child map where I am creating a key AB, and this key is created with a simple trick that whichever out of V1 and V2, whichever will be the least index number, that will be my V1 and second one will be V2. So I am concatenating them. So, in this way I am getting a perfect unique key. So like this I have calculated for each edge on the face, and then storing them in the new vertices array of the new mesh, and incrementing the vertices count. If it's a new vertex found, I'll increment, otherwise I'll use the already calculated new vertex. After that, I am associating all the vertices in the faces, new faces of the new mesh, and then I am going to smoothen the control vertex that is already present in the mesh. So I am using the simple formula that it has given, and since I have adjacency vertices, it gives me the valence, the size of the adjacency vertex for a vertex. Next, I'll just implemented the formula, and from this adjacency vertex I am taking all the vertex present and adding it up and scaling it to beta, and then adding it to the 1 minus n beta of current vertex. So this is my loop subdivision implementation, and accordingly I have to change my main.js. In main.js, what I have done, I have to change that loop subdivision should occur only for clicking of plus and minus arrow buttons. So in some of the laptops, the plus and minus are not directly present, but arrow keys are there, up and down. So I have implemented for their use, for their easy conversion, I have implemented with up and down arrow as well. And I have done a little trick here. Whatever the mesh, if I am calculating once, I am storing it in the array of meshes. And next time when I am coming back to the same mesh, I am just rendering that mesh from the index. So let's see the code. How is the rendering of our code? Okay, where is my Google Chrome? Yeah, Chrome is here, and localhost where I have hosted my application. This is the original mesh. Now, if I'll go up with first LoopSubdivision, you can see the smoothing, right? Next level, second. See how smoothen it becomes after loop subdivision and smoothing. Next, level 4, and this is level 5. So it will be become like a black small monkey outline with bright yellow spot. Now let's go back down to 4, down to 3, down to 2, and down to 1. Okay, I have drift up, down to 1, original one, and this is my original mesh. Now the main problems that I faced while implementing this is bookkeeping. Once I flip the keys, v1 comma v2, and I was not able to fetch the v2 comma v1. That's why I have implemented the simple logic of selecting whichever is the minimum one will be my v1, so that I should not forget it. Then if you don't give exact count of vertices, then you will get some spiny edges kind of Suzannes. And yeah, calculation of edge count is very important here. Then you should go in naming, storing the faces in very a particular way, whatever way you are using, either clockwise or anti-clockwise. Otherwise, you will mess it up. And I have used simple naming convention so that it can be easier for debugging, like vertex A, then whatever the new vertex is coming from A and B vertices, I'm keeping it as new vertex AB. So this make my coding easier. And then yeah, I have also implemented for rasterization. Let's go up. Yes, up 1, up 2. See the smoothness of the curve. Up 3, up 4, up 5, and FPS has gone down. Now I'll come back. And this is the original mesh. So that's all for my side, and thank you for watching my video.